Siberia is not a destination, it is another world. From frozen taiga forests to volcanic plateaus covered in snow year-round, this immense land hides ancient mysteries and extreme beauty rarely seen by travelers. Winters here can last for months, with temperatures dropping below -50 degrees Celsius, while permafrost forms the foundation of entire cities. Some places were once industrial centers of the Soviet era and now stand as abandoned ghost towns. Other places feel sacred, shaped by indigenous beliefs and guarded by sedimentary rock formations that have stood for hundreds of millions of years. Here, nature is not just a backdrop, it is a force of survival. And now, join us on a journey to uncover the most remote and breathtaking corners of Siberia, where the boundary between humanity and the wild grows thin. Mutnovsky Volcano. Fueled by deep magma activity under the Kamchatka Peninsula, Mutnovsky Volcano operates as an active volcanic system with a wide crater releasing constant heat and steam that enable direct observation of geothermal processes in cold conditions. Surrounding elevations exceed 7,540 feet, where rock layers show strong alteration caused by heat, sulfur emissions, and hydrothermal reactions. Continuous thermal discharge forms year-round snow-free zones, allowing researchers to document mineral crystallization and steam movement within a volcanic environment. Located in a region of significant tectonic influence, Mutnovsky's hydrothermal field is closely monitored to evaluate pressure and temperature shifts within its deep magma system. With steep terrain and a cold climate, Mutnovsky Volcano serves as a key research site for studying gas venting, thermal variation, and climate effects on active volcanic structures in Kamchatka. Chukotka Autonomous Okrug. Located in the far northeastern sector of Siberia, Chukotka Autonomous Okrug spans territory between the Pacific Ocean and the Arctic Ocean, forming one of Russia's most severe climate zones, with strong winds and winters lasting more than 8 months. Its landscape includes frozen plains, eroded coastal sections, and low mountain ranges averaging 1,970 feet in height, shaped by long-term tectonic activity along the Pacific margin. As a region bordering the Arctic, Chukotka is essential for monitoring sea ice changes, cold ecosystem behavior, and climate conditions that directly influence polar environments. More than 3,700 miles from Moscow, it serves as a strategic area for cold region geography studies, northern maritime routes, and observations related to near Arctic Ocean currents. Within this expansive Siberian setting, Chukotka illustrates how a harsh climate zone remains crucial for scientific research and environmental monitoring across the polar region. Lake Baikal, Irkutsk region. Located in the vast Siberian interior, Lake Baikal is recognized as the world's oldest and deepest freshwater lake, formed about 25 million years ago and reaching depths near 5,380 feet. Containing nearly 20% of the planet's unfrozen fresh water, the lake is supplied by hundreds of inflowing rivers and a stable seasonal hydrological system. Situated roughly 44 miles from Irkutsk, the region serves as an essential site for studying tectonic activity, climate history, and species that evolved in isolated conditions. Its winter ice can reach thicknesses close to 3 feet, producing long surface fractures created by strong temperature shifts that reshape the ice layer each year. Through these geological and ecological features, Lake Baikal illustrates the significance of an ancient rift lake in scientific research, biodiversity conservation, and climate observation in Siberia. Lena Pillars Nature Park. Located along the Lena River in eastern Siberia, Lena Pillars Nature Park is formed from limestone layers dating back about 500 million years, creating narrow vertical formations that extend for many miles. These pillars reach an average height of 980 feet, shaped by tectonic uplift, combined with repeated freeze and thaw cycles across ancient glacial periods. Situated roughly 110 miles from Yakutsk by river, the park serves as an important site for studying ancient climate conditions, geological evolution, and deep fossil layers preserved in Siberia. Recognized by UNESCO, Lena Pillars represents a clear geological record of Earth's long history, displayed through rock layers altered, eroded, and exposed over hundreds of millions of years. In the vast landscapes of Siberia, the park illustrates how natural processes acting over immense timescales can form distinct vertical stone structures shaped entirely by environmental forces. Novosibirsk. Located in western Siberia, Novosibirsk has grown into a major urban center built on stable lowland terrain shaped by cold continental climate. Winters last several months, with temperatures far below zero, influencing soil behavior, water systems, and material expansion. Its subsurface consists of thick sediment layers and seasonally frozen ground, requiring deep foundations and thermal protection for large structures. Summer warmth increases surface runoff and modifies soil moisture, allowing observation of seasonal ground variation. Situated more than 1,740 miles from Moscow, the city functions as a key hub for research, transport, and industry under persistent cold climate conditions. Through its climate, geology, and urban layout, Novosibirsk demonstrates how large cities operate within Siberia's extended cold environment. Altai Mountains. Stretching across the boundary of major Eurasian tectonic zones, the Altai Mountains rise to average elevations exceeding 9,840 feet. forming steep ridges and deep valleys characteristic of southern Siberia. Their bedrock of granite, metamorphic formations, and ancient sediments provides strong resistance to wind erosion and seasonal freeze-thaw cycles. Long winters with temperatures far below zero create extensive ice cover that shapes rock weathering and slope stability. Short summers supply enough sunlight for cold-adapted vegetation while generating runoff that carves channels across steep terrain. With stable geological structure and pronounced climatic gradients, the Altai Mountains serve as a key region for studying high mountain evolution under cold continental conditions. Onakotan Island, Krenitsan volcano. Shaped by the collapse of an ancient volcanic structure, Onakotan Island contains the Krenitsan caldera, a large crater filled by a deep lake that surrounds a central volcanic island formed through later eruptive activity. The caldera measures nearly 4 miles across and holds a lake with an average depth of about 660 feet, supplied by precipitation and seasonal snowmelt. Through its isolated setting and multi-layer volcanic structure, Onakotan Island demonstrates how ancient eruptions shape complex landscapes of crater lakes, inner cones, and steep surrounding ridges. Katu Yarik Pass and Chulishman Valley. Shaped by intense mountain uplift and glacial erosion, Katu Yarik Pass descends nearly 2,620 feet into Chulishman Valley, a deep corridor carved over thousands of years by persistent ice activity. Its steep rock faces and zigzag descent rely on multi-layer foundations designed to withstand deformation caused by seasonal freeze-thaw processes. Chulishman Valley lies roughly 3,280 feet below surrounding peaks, containing glacial deposits and seasonal runoff that form a key setting for studying valley formation in Siberian mountain regions. The area experiences cold continental winters with temperatures capable of affecting bedrock stability and slope behavior, requiring infrastructure adapted to shifting ground conditions. With its combination of steep passes, deep valleys, and long-term glacial shaping, the Kartu-Yarik and Chulishman region illustrates how tectonic movement and cold climate processes sculpt complex, high mountain landscapes. Sakhalin Island, Russia. Formed by the interaction of the Eurasian and Pacific tectonic plates, Sakhalin Island is the largest island of the Russian Far East, stretching nearly 590 miles, with geological features ranging from young mountain chains to coastal lowlands shaped by a cold climate. The island consists of layered, sedimentary and metamorphic rocks that create mountain ranges averaging about 1,970 feet in elevation and seasonal basins influenced by snowmelt. Positioned several hundred miles from mainland Russia, Sakhalin plays an important role in studying tectonic motion along the Asian margin, particularly the long-term effects of Pacific Plate convergence. Its river systems are primarily fed by spring snowmelt, forming stable water channels that support the island's cold, adapted ecosystems. Through its combination of tectonic activity, harsh climate, and coastal geography, Sakhalin Island represents a critical natural laboratory for understanding Earth science and northern environmental dynamics. Olkhon Island and Cape Burkan. Located at the center of Lake Baikal, Olkhon Island and Cape Burkan are considered one of the most sacred areas of the Buryat people, where traditional shamanic practices have been preserved across generations. The island stretches nearly 43 miles and features cliffs, long sandy shores, and dry steppe landscapes shaped by geological activity over millions of years. Cape Burkhan is marked by granite and marble formations reaching an average height of 130 feet, recognized as a key ceremonial site due to its distinct structure and position facing Baikal's deeper waters. Situated about 3 miles from the western shore of Lake Baikal, the area serves as an important location for studying indigenous culture, migration history, and nature-based belief systems in Siberia. Through its combination of ancient geology and long-standing traditions, Olkhon Island and Cape Burkhan demonstrate how a sacred landscape is shaped by both environmental forces and cultural heritage. Katun River. Originating from high-altitude permafrost zones in the Altai Mountains, the Katun River extends nearly 435 miles with year-round, cold water influenced by continental climate and seasonal snowmelt. Its basin lies on granite and metamorphic bedrock, allowing the river to maintain fast flow rates with limited sediment accumulation. Spring melt increases discharge and accelerates erosion through narrow channels, while autumn brings reduced flow as seasonal runoff declines. Winter temperatures often freeze surface layers along certain sections, providing conditions for observing thermal stratification beneath the ice. Through its variable gradient, cold water regime, and stable geological base, the Katun River serves as a key hydrological system for studying erosion and cold climate river dynamics in the Altai region. Teletskoye Lake. Positioned in the northern Altai region, Teletskoye Lake is a deep tectonic basin extending nearly 50 miles with an average depth exceeding 984 feet, supplied year-round by cold mountain inflows. Its bedrock consists of metamorphic and granite formations that preserve a narrow and deep basin with minimal sediment accumulation. Winters last for several months, during which the lake surface can freeze to substantial thickness depending on temperature variation. Short summers increase water circulation and reveal thermal layering and mixing processes characteristic of Siberian mountain lakes. Through its stable geology, significant depth, and consistently cold water, Telitskoye Lake serves as a key site for hydrological and environmental study in the Altai Mountains. Chara Sands. Located within the cold interior of Siberia, Chara Sands forms a rare sand field nearly 6 miles long, standing adjacent to wetlands and coniferous forests. Its sand originates from ancient glacial sediments that winter winds have reshaped into dunes, averaging about 49 feet in height. Extended winters with temperatures far below zero freeze the surface layers, creating temporary crusts that melt during warmer months. With its sharp contrast between dry dunes, frozen ground, and surrounding taiga, Chara Sands illustrates how ancient deposits persist in Siberia's extreme environment. Yakutsk, Sakha Republic. Located in the deep cold zone of the Sakha Republic, Yakutsk stands out as a major city shaped by sub-Arctic conditions where winter temperatures fall below -58 Fahrenheit and create a demanding climate for daily life. The city is built on permafrost layers, averaging 820 feet in depth, requiring engineering systems designed to minimize the impact caused by seasonal shifts in frozen ground. Positioned more than 5,200 miles from Moscow, Yakutsk serves as a key center for cold climate research, mineral extraction, and technological development across the Russian Far East. Its annual rhythm is defined by strong variations in daylight, with only a few hours of winter sun and extended summer brightness shaping local activity patterns. Within these extreme conditions, Yakutsk demonstrates how an urban community can be sustained in one of the most challenging environments in Russia. Vladivostok. Extending across rugged Pacific peninsulas and steep shoreline ridges, Vladivostok operates as a major maritime hub where port systems and transport networks adapt to irregular coastal terrain. Its narrow landforms contain mixed bedrock and coastal sediments, requiring deep foundations to stabilize large structures against shifting moisture and temperature conditions. The local climate combines continental cold with strong marine influence, producing winters far below freezing and summers marked by dense fog that affects navigation. Urban routes follow tiered layouts to link areas divided by steep slopes and segmented bays. Located more than 3,980 miles from Moscow, the city functions as the eastern terminus of the Trans-Siberian Railway and a key gateway to the Pacific. Through its coastal geography and cold maritime environment, Vladivostok demonstrates how a major port city maintains stable operations under dynamic natural conditions. Chuya Highway, Altai Mountains. Developed to link remote valleys of southern Siberia, the Chuya Highway crosses the Altai Mountains at average elevations near 4,920 feet, where extended cold seasons leave the roadway covered in ice for months. Its route spans steep rock slopes, narrow valleys, and seasonal snowfields, requiring multi-layer road foundations to reduce deformation caused by freeze-thaw cycles. Stretching roughly 385 miles, the highway serves as a key corridor for studying cold region transportation, including load behavior and temperature-driven ground movement. Located near the northern edge of the Altai Range, the area is exposed to strong winds and heavy snow, creating a demanding environment for road engineering. Through its combination of mountain terrain and continental cold climate, the Chuya Highway demonstrates how infrastructure can be designed for stable performance under severe natural conditions. Ergaki National Park, Western Siam. Shaped by long-term tectonic uplift, the Ergaki Range rises to average elevations of about 7,210 feet and contains multiple cold glacial lakes set within steep granite terrain. The granite formations developed from slowly cooled magma, producing vertical cliffs and deep grooves that have been modified by freeze-thaw cycles. Its combination of narrow valleys, steep ridges, and deep glacial basins provides important context for studying young mountain landscapes in Siberia. Located roughly 37 miles from nearby urban areas, the region experiences cold continental winters with temperatures dropping far below freezing, influencing rock stability and slope formation. Through its interaction of ancient granite, persistent snow, and tectonic processes, Ergaki National Park serves as a key natural setting for geological and environmental research in the Western Siam Mountains. Stolby Nature Reserve, Krasnoyarsk. Formed through long-term uplift of granite massifs in central Siberia, Stolby Nature Reserve features towering rock pillars averaging around 328 feet high, standing prominently within the cold taiga landscape. These formations originated from slow-cooling magma millions of years ago, producing steep vertical faces and surfaces shaped by continuous cold climate weathering. The region experiences extended winters where temperatures fall well below freezing, influencing natural rock fracturing and long-term structural stability. With its combination of taiga forest and prominent granite pillars, Stolby Nature Reserve illustrates how ancient geological structures evolve under persistent Siberian environmental forces. Kamchatka Peninsula. Formed along the northern extension of the Pacific tectonic belt, the Kamchatka Peninsula developed through continuous volcanic activity that produced cones, geothermal vents, and ancient lava fields surrounded by year-round snow at higher elevations. The peninsula extends more than 750 miles and is shaped by volcanic ranges with average elevations close to 8,200 feet, created through long-lasting subduction processes beneath the Pacific margin. Situated between the Pacific Ocean and the Bering Sea, the region is one of the few places where snow, magma, and geothermal systems can be observed interacting within the same landscape. Roughly 220 miles from Petropavlovsk-Kamchatsky, the area serves as a major research center for volcanic dynamics, magma chamber development, and long-term geomorphological change under cold climate conditions. Across its expansive and geologically active terrain, the Kamchatka Peninsula demonstrates how a volcanic environment can sustain prolonged activity while contributing valuable knowledge to Earth science and polar environmental studies. Putorana Plateau, Krasnoyarsk Krai. Located within the remote region of Krasnoyarsk Krai, the Putorana Plateau is one of the largest basalt formations on Earth, created by massive lava flows that shaped a wide terraced landscape extending for hundreds of miles. The plateau reaches an average elevation of 3,280 feet and is dissected by deep valleys and extensive glacial lakes formed through natural fracturing of basalt over long geological periods. Approximately 190 miles from Norilsk, the area contains numerous waterfalls averaging around 330 feet in height, supplied by seasonal meltwater and the hydrological cycle of northern Siberian rivers. Recognized by UNESCO, the plateau represents a significant record of ancient basalt formation combined with a near-untouched subarctic ecosystem. Across its vast and cold environment, the Putorana Plateau demonstrates how long-term geological processes create a highland defined by deep lakes, vertical cliffs, and seasonal ice-fed waterfalls. Kadikshan Ghost Town. Located in a remote region of eastern Siberia, Kadikshan Ghost Town remains as a surviving remnant of the Soviet era, once built to support coal miners before being abandoned in the late 1990s. The settlement includes concrete buildings averaging 4 to 5 stories in height, along with a street network that has deteriorated after decades without maintenance. More than 370 miles from Magadan, Kadikshan stands as a clear example of population decline in mining towns of the Russian Far East during the post-Soviet economic transition. Under these conditions, Kadakchan shows how an industrial community can disappear entirely within a short historical period. Oymyakon, Sakha Republic. Located in the deep cold region of the Sakha Republic, Oymyakon is recognized as the coldest inhabited place on Earth, where winter temperatures can fall below -76 Fahrenheit and create one of the most extreme climates known. The settlement rests on permafrost layers, averaging 820 feet in depth, requiring adapted construction and daily routines that account for seasonal ground changes. More than 5,400 miles from Moscow, Oymyakon serves as a significant location for studying cold climate resilience and human physiological endurance under severe temperature conditions. Its residents live under extended winter periods with very limited natural light, leading to outdoor activities being adjusted for safety throughout months of freezing weather. Amid this extreme environment, Oymyakon demonstrates how a community can remain stable in what is known as the pole of cold for human settlement.